Good day. My name is Christine Miller, a student at the California Intercontinental University.
Today, I will be speaking on correlation analysis. This would include analyses of tests that were done which had significant results based on the hypotheses that were developed. After which, we will look on any takeaways from them, and then we'll field questions. The data was gathered from responses from a sample of persons in Midwest of the USA in regards to questions regarding their income, debt, savings, and other important personal finance factors. For all the tests, the level of significance, or alpha, was set at 0.05. The first significant result was found when income and savings were tested. The null hypothesis was that there is no correlation between income and savings, while the alternative hypothesis was that there is a correlation between income and savings. The analysis revealed a correlation of 0.91 and a p-value of 0.000. Given that correlation is close to 1, this correlation is significant, and the graph should show that there isn't much deviation from the line of best fit. Here is the graph, and as expected, the data points are closely grouped around the line, and they are reflecting a positive level of significance, as when income increases, savings are increasing as well. Therefore, the null would be rejected. In the second test, income and stocks were compared, the null being there is no correlation between income and stocks, and the alternative being there is a correlation between income and stocks. The results were that correlation was 0.19 and the p-value was 0.018. Not as strong as the first test, but still reflecting that there is correlation between the two. The scatter plot can be expected to be more dispersed, but still reflecting the correlation between the two variables. As we can see, the data points are more scattered, but still there is a strong level of correlation. Therefore, the null would be rejected. The third test shows a comparison between income and the amount of money that is carried in their wallet. Using PSPP again, the level of correlation was at the maximum value of 1, with a p-value of 0.000. This means that there is no variation between the data points and the line of best fit. So when we look at the graph, we can expect to see all the data points on the line. Here is the graph reflecting the result as described. With R at 1 and P at 0, the null hypothesis will have to be rejected. The next test is between savings and stocks, with the null being that there is no correlation between savings and stocks, and the alternative being that there is a correlation between savings and stocks. The results showed a correlation of 0.28 and a p-value of 0.000. The correlation is below alpha, and with the p-value of 0, we know that the null must be rejected, as there is a correlation between savings and stocks. Looking at the graph, we see that there is a positive relationship, as when savings increases, stocks also increases. The fifth test is between savings and wallet. The hypothesis used for this is that the null is that there is no correlation between savings and wallet, while the alternative is that there is a correlation between savings and the wallet. This is similar to the test with income and savings, and the graph will also be similar, with the data points being more dispersed around the line, and also the conclusion that the null must be rejected, as there is a correlation between savings and the amount of money in a person's wallet. The final test is with stocks and the wallet. This correlation was to determine if as stocks moved, if the amount of money kept in their wallet would also move. The correlation was significant at 0.19 with a p-value of 0.018. While this R value is close to 0, it is still significant. The graph shows a large scattering of data around the line. But there is a correlation as the level of investment in stocks increases when the amount of cash in their wallet increased. Therefore, the null hypothesis would be rejected. Here are some important takeaways. The level of correlation, R, is always between -1 and +1. Also, the correlation can be presented graphically on a scatter graph, which can be used in support of the calculations. Next, this graphical representation can also be used as a quick analysis without the calculations. Also, software such as PSPP is an essential tool for researchers to use to do their analysis. Also, the hypotheses have to be carefully crafted, otherwise the results will be incorrect. That is, the null must be identified as reflecting no relationship with the variables. In terms of the tests that were conducted, we can surmise that once an individual is earning an income, there are significant relationships with the level of savings, amount of stocks they invest in, and the amount of money they carry in their wallet. And finally, that there is a significant relationship between the level of savings and amount invested in stocks, but there is an even stronger relationship between the savings and the amount of money that they keep in their wallet.